Hey guys, what's up everyone? Welcome or welcome back again to another video tutorial lesson from the AP3X Institute of Mathematics. My name is Akeen, your math instructor, and in today's video we're going to be looking at solving a quadratic equation by the factoring method. Now, a previous video was actually uploaded on the channel. I will leave a link in the description box below, and of course I'll leave a link pinned in the comment section. You can check out that video about how to factorize a quadratic expression using the AC method. So by extension, this video is by extension of the one that was previously done. So if it is that you are unaware of the technique that is being used here, please be sure to go ahead and watch that video. Then of course this one will make a lot more sense to you. So alright, so we're just going to be picking up on where we left off a few months ago on the quadratic expression. Now we're extending it now to an equation. If this is your first time here on the channel, consider smashing the subscribe button below. Leave me a like, leave your comments, suggestions and video requests down in the comment section below, and let's just get better at this wonderful subject and this language of the universe. All right, so here we go. So you would have been or should have been very familiar with what a quadratic expression looks like, and it generally takes the form ax squared plus or minus bx plus or minus c. By extension, if it's an equation, then it must be equal to 0. So this is the general form. Now, we have already established that a, b, and c are constants, where a is the constant or the coefficient of x squared, b is the coefficient of x, and c is, of course, the constant here. All right. Now, in videos to come, you're going to be seeing more methods in which an equation like this can be solved. And so you're seeing here that there's actually 3 ways in which we can get the solution to an equation that has this format. We have the AC method, which is primarily what this video is about. Then we have the quadratic formula, which is going to be my next upload. And coming up, you're going to be seeing a method known as completing the square in 2 different ways. So lots of content to come, guys. To be notified of these video tutorials and lessons, be sure to smash the subscribe button below and turn on the bell. Alright, so the emphasis of this particular tutorial here is to look at solving the quadratic equation by the factoring method. Now I have a bunch of questions here that I have structured for you, and we're going to be going through about 8 or so examples, right? Not too difficult, but we're going to be going through some examples looking at when the leading coefficient is 1 and looking at when the leading coefficient is greater than 1. Alright, so you guys would have already been familiar with the whole concept of solving factoring quadratic expressions. So we're going to be using that technique then to actually solve the quadratic equation in this particular tutorial. Alright, so you would have been aware that the very first method in solving or factoring an equation here would have naturally been where we have to find the product of a and c. So that is you multiplying the a here by the c here. Okay, let's just do that better. So we have a here times c here. All right, and so you would have been familiar with the fact that the leading coefficient here is 1. So that's going to be 1 multiplied by 3, and the product AC is equal to 3. All right, now these questions are usually very simpler than some of the more advanced ones, obviously, because the product is very small, and in this case the product is a prime number. So there's not much consideration when it comes to choosing your factors, because since 3 is a prime number, then 1 and 3 is your only possible factor that can produce the middle term. And then obviously then we know adding 1 to positive 3 should give us positive 4. So those are our selected factors. We would then proceed to say x squared, and we would now substitute the 4x with the factors that we have selected, which is going to be here 1x plus 3x, which obviously adds up to being 4x, and then we just add this 3 here. Okay, let me just rewrite this question a little lower. All right, good. And then now here's what we have. Now we're going to be factoring by grouping. All right, so we're going to be factoring the first 2 and factoring the last 2 in pairs. Okay, so the common factor of x squared and x is x, and x divides into x squared goes x times, and x into 1x goes 1 time. Right, 3 is our common factor here, so that's positive 3. 3 into 3x goes x times, and 3 into 3 goes 1 time. And let's not forget to equate our answer to 0. Alright, now the factoring aspect is completed. So therefore our result of the factoring is x plus 1 by x plus 3. And that's equal to 0. Alright, and so that's where the factoring aspect of the quadratic equation ends. Now by extension we need to solve for the value of x. So we have a product of 2 binomial expressions here being equated to 0. So that simply means that the first factor is going to be equal to 0, and the second factor then also is going to be equal to 0. We will then solve the basic linear equation. Transposing the 1, we end up with x being equal to minus 1, and we transpose the positive 3, we end up with x being equal to minus 3. So these are our 2 solutions that will produce a 0 for this particular equation here. Alright, so definitely for what has been done here, I already have a link pinned in the comment section below. Click on that link, it will take you to the video that will explain in details this technique known as the AC method. So definitely check that out. Let's move right along now to a few more advanced questions. Well, not a few more advanced questions, obviously, but we're going to move on to another example, right? Another example. So here we have x squared subtract 5x plus 4 equals 0. Same procedure. We're going to be finding the product of a times c. All right, so here we have a, which is the number in front of the square, times c. All right, so that is a times c. So now we'll end up here with 1 multiplied by positive 4, and that's equal to 4. All right, now 4 is not a prime number, so it more than likely has more than one pair of factors. So we know that 1 multiplied by 4 gives us 4, and we also know that 2 multiplied by 2 gives us 4. So we have to make a decision as it relates to which factor will produce the middle term. Now clearly 1 and 4 is most likely the one that we're going to be choosing, but we need to produce a negative 5. So we cannot make this positive or this positive, because we're going to be producing a positive 5. We're interested in producing a negative 5. So what we're going to be doing here is that we're just going to be making both of them minus. So that minus 4 subtract 1, or negative 1 subtract 4 will produce negative 5. Alright, so we're going to take those factors that we've selected here and put them in the middle. So that's going to be x squared, right? And we're going to subtract 1x, and we're going to subtract 4x, and we're going to be adding 4. And of course, don't forget to equate our expression to 0, right? Beautiful. Now we're going to be factoring by grouping. All right, I think I may have written these questions a bit too close, guys, so yes, okay. All right, so here we go. Now we're going to be factoring by grouping, so the first 2 here and the last 2 here. Okay, common factor of the first 2 is x. X divides into x squared goes x times, and x into minus 1x goes minus 1 times. Common factor of negative 4x and 4 is going to be negative 4. Negative 4 divides into negative 4x goes x times. Negative divides into positive is negative. 4 into 4 goes 1 time, and that's equal to 0. So again, the factoring aspect of our expression here is of our equation here is completed. The common factors are x minus 1, and obviously the remaining factor is x take away 4, and that there is equal to 0. So naturally, because we have a product of two binomial expressions being equated to 0, then it simply means that x minus 1 is going to be equal to 0, and x minus 4 is going to be equal to 0. Solving the equations here very simply, x then works out to be 1, and naturally here, x here works out to be positive 4. Okay? So really nice problem solving there when it comes to the quadratic equation. Alright, let's do another example. Here we go. Let's just rewrite this question down here so we do not forget what it is. And then we're going to come and work out question number 3. Okay. Alright, here we go. So we have done an example where we have a plus plus. We've done an example where we have a minus plus. Let's look at an example now where we have a plus minus. Let's see how that's approached. And so far, all our examples have a leading coefficient of 1. There's no other number in front of the x squared. Now, in the second, or as we continue the video, we're going to be seeing examples where the leading coefficient increases to more larger numbers. Okay, so here we have 1 multiplied by 7, or I should say 1 multiplied by minus 7. So that's 1 multiplied by minus 7. And that's equal to minus 7. And once again, we end up with a really nice value here that's not too complicated here. Alright, 7 is indeed a prime number, so it only basically has one pair of factor. So we need to produce a positive 6 from the pair 1 and 7. So clearly, it would only have to be positive 7 and negative 1, because positive 7 take away 1 will produce positive 6. So we end up here with x squared. So we end up here with x squared plus 7x. Or I should say, it doesn't really matter which one I put first though. So it's x squared minus 1x plus 7x minus 7 equals 0. Alright, I'm going to be factoring by grouping. Common factor for the first two here is going to be x. X divides into x squared goes x times. X into 1x goes 1 time. But negative 1 times. Common factors on the right side here is going to be positive 7. 7 divides into 7x goes x times. 7 divides into negative 7 goes negative 1 times, and that's equal to 0. Alright, so naturally then let's just go across here. See if we can get some space. So that's x squared minus 2x minus 1. Is that it? Let's see here. Alright, that's it. Alright, so I need some space, guys. I think I may have written these questions a bit too close. Alright, good. Here we go. So what we have now is simply common factor here is going to be x minus 1, and the remaining factor is going to be x plus 7 equals 0. So therefore then, we have a pair of binomial expressions, or we have a product of two binomial expressions. Therefore, x minus 1 is going to be equal to 0, and x plus 7 is equal to 0. Transposing here, we end up with x being equal to 1. Transposing here, we end up with x being equal to minus 7. Okay, and that is basically how we can solve a quadratic equation by the factoring technique. Alright, now I do have an additional question down here that I want us to look at. So I'm going to go across to another page here. So that's going to be x squared minus 2x minus 1 equals 0. Let's hop onto that one. So once again, same procedure. That's going to be 1 multiplied by minus 1. And that's going to be equal to minus 1. It's going to be equal to minus 1. If if I stand, I don't think I made this question, I don't think I've written this question correctly. I think this should actually be a 1. Right, this should be a 1. There we go. Should not have been a 2, guys. Don't think that that's factorable. Alright guys, so as it relates to that particular question, I think I may have made an error with the numbers. I think that our constant here should have been a 2, not in factor 1. So the middle term here should have been a 1, a minus 1, and the end term here should have been a minus 2. So therefore we would have had here 1 multiplied by negative 2 should have been equal to negative 2. So once again, 2 is a prime number. So we'll end up with a pair factor of 1 and 2. And that's the only pair that can produce, that's the only pair for 2. And it's the only pair that can produce a negative 1. So we're going to have a negative 2 here and a positive 1. That's the only way that we can produce a negative 1 for our middle term. So we end up here with x squared. Right, we're going to replace the middle term here with what we've selected. So that's x squared plus 1x minus 2x minus 2 equals 0. And so therefore then what we're looking at now is factoring by grouping. Okay, so we're looking at here, the common factor here is x. X divides into x squared goes x times, and x into positive 1x goes 1 times. Common factor to the right side here is negative 2. Negative 2 divides into negative 2x goes x times, and then negative 2 divides into negative 2 goes positive 1 times, and that's equal to 0. So therefore what we have naturally here is just going to be x plus 1 as our common factor, and x take away 2 as our remaining factor equals 0. Now simply we have two binomial expressions, product of two binomial expressions being equated to 0. So we end up with x plus 1 being equal to 0, and we end up also with x minus 2 being equal to 0. So transposing here, we end up with x being equal to minus 1, and transposing here, we end up with x being equal to positive 2. So those are our solution to our equation, or quadratic equation, so to speak. Alright, so that's an example now, guys, where our actual leading coefficient is 1. When I say leading coefficient, I mean the coefficient that is in front of the variable with the largest power. So now it gets a little bit more interesting now when we're looking at examples where the leading coefficient is greater than 1. And so it's the same technique, everything remains the same, with the exception that you may end up with a little more bigger factors, and you may end up with factors with double choices where you have to make a decision as to which one is best to produce the middle term. So let's have a look at a few examples of these here and see if we can wrap this up. So we end up with an equation here that says 2x plus 5, 2x squared plus 5x plus 3. Nothing has changed. We're going to be multiplying here 2 by 3. So we end up with 2 times 3 here. That works out nicely to be 6. 6 has a couple of pairs of factors. That's 1 and 6. And obviously 2 and 3. Now, here's where we have to make a decision as it relates to which one of these will produce the positive 5 and at the same time produce the positive 6. Both can produce positive 5, because if I make 6 positive and I make 1 negative, I'll still get 5. And if I make 2 positive and I make 3 positive, I can still get 5. So both pairs of factors can produce 5, but I also need to choose the one that will produce a positive 6. Now if you look carefully, that 6 multiplied by negative 1 will give negative 6. But 2 multiplied by positive 3 will give a positive 5, positive 6. So positive 2 and positive 3 produces the middle term, and it also produces the product of A and C. So therefore my selected factor here is going to be 2 and 3. So here we go then. We're going to have 2x squared. Then we're going to have positive 2x, positive 3x, plus 3 equals 0. Alright? And then now clearly now we're going to be factoring by grouping. So here, the common factor here is going to be obviously 2x. 2x divides into 2x squared goes x times. And 2x divides into 2x goes 1 time. Common factor here is going to be positive 3. And then we have 3 divides into 3x goes x times. And 3 into 3 goes 1 time. And that's equal to 0. So naturally then we have a pair of common factors here, which is x plus 1. And the remaining factor here is going to be 2x plus 3 equals 0. So now we have a pair of factors, or a pair of binomial expressions, or product of two binomial expressions being equated to 0. Then therefore we end up with x plus 1 equals 0. And we end up with another pair here. Let's solve this one first. So if we solve this one, we're going to find that one of the results is that x is equal to minus 1. And if we were to go ahead now and kind of zoom up here a little bit, guys, if we were to take 2x plus 3 and equate it to 0, if we transpose the 3 here, we're going to end up with 2x being equated to minus 3. And if we divide both sides by 2, we'll end up with x being equal to minus 3 over 2. So that would be our second solution for x here. I do apologize for this space that was not created to make it clear for you, but hopefully you're following as I'm going through the steps. Here would have been the solution for one possible solution of x, and this would be another possible solution for x. Okay? So hopefully you're getting a clear understanding of how to solve an equation, a quadratic equation to be precise, using the factoring technique. Let's look at another example here. Alright, and here, same procedure, we're going to be multiplying 3 by negative 8. So we end up with negative 24. And we're looking for a pair that could possibly produce the middle term of 2. So most of you guys probably will know that the answer is going to be 6 and 4. But there are other factors of 24. You have 8 and 3, 12 and 2, and 8 and 3, 12 and 2, 6 and 4, and 1 times 24. Those are all possible other pairs that in the event that the middle term was a different number, maybe one of these pairs we would have selected. But clearly you can see here that the selected factor is going to be 6 and 4. And the only way to get back a positive 2 is to make the 6 positive and the 4 negative. Multiplying 6 by negative 4 gives negative 24, and taking away 4 from 6 produces positive 2. So let's plug them in the middle. We end up with 3x squared. End up with 3x squared plus 6x minus 4x minus 8 equals 0. So the common factor here for the first two is going to be 3x, obviously. 3x divides into 3x squared goes x times. And 3x into 6x goes 2 times. Common factor on the right side here is going to be positive 4. Negative 4, pardon me. Negative 4 into negative 4x goes x times. Negative 4 into negative 8 goes positive 2 times. That's equal to 0. So naturally now we end up with a pair of factors of x plus 2, which is common. And we end up with 3x minus 4. And that is also equated to 0. So we end up with two binomial expressions being multiplied, and they're also equated to 0. So one of them is going to be that x plus 2 is equal to 0, and 3x minus 4 is equal to 0. This one's a little easy to solve because it's just a basic transposition. X is equal to minus 2. This one now we have to transpose the negative 4, so we end up with 3x being equal to positive 4. And if we divide both sides by 3, we end up with x being equal to 4 over 3. So that would have been the solution here for that particular equation. Okay, so hopefully you guys got a hang of that. Let's work another example. All right, wrapping up, coming to the end of the video here, guys. So let's see if we can get a little bit more interesting. So here we have 5 multiplied by 4. that's 5 times 4, that's going to be equal to 20. And I need to produce the result of negative 12. So if you look at it, probably you're going to see that it's 10 and 2, both negative. Okay, but remember that we also have other factors like 5 and 4 and 1 times 20. Those two can also produce other middle terms. But for this particular example, negative 10, negative 2 is going to produce negative 12, and at the same time multiplies to produce 20. So 5x squared minus 10x minus 2x plus 4 equals 0. You'll find here that the common factor is 5x. 5x into 5x squared, pardon me, 5x into 5x squared goes x times, 5x into negative 10x goes negative 2 times. Common factor here is going to be minus 2. Minus 2 divides into minus 2x goes x times. Minus 2 divides into positive 4 goes minus 2 times, and that's equal to 0. So the common factors are going to be x take away 2 multiplied by 5x take away 2. And that's equal to 0. So once again, x minus 2 equals 0. Naturally, x is going to be equal to 2 by transposition. And of course, you have 5x take away 2 equals 0. Transpose to negative 2. 5x is going to be equal to positive 2. Therefore, x is equal to 2 over 5. And that produces the answer for that particular equation. So you guys, you've got to make certain that you have a very clear understanding of the factoring method. Again, as I mentioned in the introduction of the video, there is a link provided in the comment section, pinned and in the description for a video, or you can just check my playlist under factorization or factoring. You'll find a video that will explain in details all the steps of how to use the EC method. Let's bring this video to an end and look at factoring this final question here. Leading coefficient is 6, so that's 6 multiplied by 3. Pardon me, 6 multiplied by minus 3, that's minus 18. And so 9 and 2 is going to be the possible factor. Of course, we have 1 and 18 and 6 and 3 that could possibly produce other middle terms, but we're looking at extracting a negative 7. So the only way to do that is to use the pair factor 9 and 2, making the 9 negative and the 2 positive. So naturally here, 6x squared minus 9x plus 2x, pardon me. Let's just make it a little easier for factoring. So it's 6x squared plus 2x minus 9x minus 3 equals 0. Now, a lot of you guys might be wondering, does it matter which one you put down first? It really doesn't, but the one you put down first will make the factoring easier. So I like to put my factors against other terms that makes the expression easily factorable. Okay, so I put the 2 beside the 6 and the 9 beside the 3 because easily I can see what the common factors are. Common factor here is going to be 2x, obviously, and 2x into 6x, well, 2 into 6 goes 3 times, and x into x squared goes x times, and 2x divides into 2x goes 1 time. Common factor on the right side here is going to be 3, and minus 3 into minus 9 goes 3 times along with the x. Minus into minus goes plus, 3 into 3 goes 1, that's equal to 0. So clearly now we end up with a pair factor that says here that it is 3x plus 1, that's the common factor, and the remaining factor here is going to be 2x plus, pardon me, 2x minus 3, and that's equal to 0. So easily now we can wrap this up simply here by saying that 3x plus 1 equals 0. If I transpose here, I'll end up with 3x being equal to negative 1. Transposition, dividing both sides by 3, I'll end up with x being equal to negative 1/3. And finally, I end up with 2x minus 3 equals 0. Transpose the 3, I'll end up with 2x being equal to positive 3. And if I divide both sides by 2, I'll end up with x being equal to 3 over 2. Alright? And so that there really wraps up the whole concept of factoring, or wraps up the whole concept of solving a quadratic equation by the factoring technique. All right, so hopefully this particular tutorial here was useful to you in terms of solving an equation in this format. Coming up next on the channel is going to be solving a quadratic equation by using the quadratic formula. Very important concept there, because you're going to find that a lot of expressions may not be factorable. So when it's not factorable, what do? We have to look at the quadratic formula. All right, so hopefully this tutorial was very helpful to you. Do hope that you subscribe, like, leave your comments, video requests and suggestions down in the comment section below, and hopefully you continue practicing and improving on your math skills. See you next time in another tutorial. Take care. Bye bye.